Okay, continuing on today, working on the Digamma function, I want to do something that I think is pretty interesting, which is trying to find exact values for some non-integer values for the Digamma function. And so in this case, we just want to find the value for Digamma of 1/2. And I think all I'm going to need for this is this definition that we have, this multiplication formula we have over here to the right for the Digamma function. And this one's really useful for calculating some of these exact values. Another thing that works really well for calculating exact values is the Gauss-Digamma theorem. But the thing about that is it's a really long formula. So I kind of like to stay away from that one just because there's like no way I can memorize it. Whereas actually I can memorize this formula. And so one thing that's going to come up when we calculate this is going to be the Euler-Mascheroni constant, which we have here. This is just a constant value that's approximately 0.577 something. Okay, so to get started with this, I just want to put to use this formula. And what I'm going to do, let's call the 1/2 our z to use in this formula. On the left side, I want to get something, a known value. So if I create my n value equal to 2, then we have just Digamma of 1 over here. But Digamma of 1, this is a well-known value. I showed this in another video. This is going to be the same thing as just minus the Euler-Mascheroni constant. So in this setup, what we have is we're saying n is going to be 2, our z is going to be 1/2. So then let's just come over here, plug everything in. So then out front, we're going to have 1/2 here. Our sum is going to be from k equals 0 to n minus 1. 2 minus 1 is 1 there. Then we're going to have Digamma of our z, which is 1/2 minus just k over n, which is 2, plus natural log of 2. And so then let's just try to simplify it and see what we have. So again, this value on the left is just going to be minus the constant. Here we have 1/2. Now, k going from 0 to 1, that's just going to be 2 terms. So the first one, when k is 0, we just get Digamma 1/2, which is going to be our goal. And then for the second one, we're going to have, when k is 1, this becomes, it's funny, I said I could memorize the formula and then I wrote it down wrong. That's a plus sign there. So this is actually a plus sign here. Mistake. So anyway, when k is 1, what's going to happen is this becomes Digamma of 1. But Digamma of 1, we just found that before. So that's going to be just minus the constant. And then we get this plus ln2 on the end. And so again, this is going to be our goal for what we want to get back to. So all I need to do is just isolate that. Let's multiply 2 on both sides in order to clean it up. So that's going to cancel out with the 1/2, and then we'll have a 2 on the front of the ln2 here. Then let's rearrange this so we have this alone on the left side of the equation. This is going to become Digamma 1/2. Then here we have minus 2 times the constant. Bringing this to the other side, this is going to become a plus Euler-Mascheroni constant. Bring it to the other side, this is going to be minus 2 ln2. Putting this together, we can combine these, and for the solution of this, we just get minus Euler-Mascheroni constant minus 2 ln2, and that's it. And then so the nice thing about having a few common values is then with other formulas, we can kind of get those from this. Like for example, let's say I was looking for Digamma of 3/2. Well, we have this recursion formula for this that just says Digamma z plus 1 is going to be the same thing as Digamma of z plus 1 over z. So for this, if we subtract 1, then we're saying this is going to be the same thing as Digamma 1/2. 1 over this, that's just going to be a plus 2, but we just found this value, so we can just plug this in, minus the constant, minus 2 ln2 plus 2, and that's going to be our value for Digamma 3/2. Okay, so there you have it. That's it for today. Thanks everyone for watching. Have a good day.